Good morning, everyone. We from Group 10 would like to present our case study, tunnel construction for Pahang Selangor Raw Water Transfer Project. So my name is Jester and my group member, Yabes, Darren, Walter, and Richard. This project is one of the most important water infrastructure projects in Malaysia. The main purpose of this project is to transfer raw water from Pahang to Selangor to support water supply in Klang, especially during the dry season. The tunnel is about 44.6 km long and the diameter is 5.2 meters. This project going through from Titi Wangsa mountain range and constructed deep underground, making it a challenging engineering project. This project helped us to understand how the tunnel construction is used to solve real-life problems such as water shortage. In this presentation, we will explain in the construction method, machinery use, challenges faces, and the overall importance of this tunnel project.
Next, I will explain the construction sequence and method used in the tunnel project. Before construction began, detailed geological and soil investigation were carried out to understand the ground condition. This is very important to choose the correct tunneling method. Two main methods were used in this project. The first method is the tunnel boring machine, also known as TBM. TBM is used in the area with the long tunnel section and stable ground. It helps to excavate the tunnel safely and efficiently. The second method is using the new Australian tunneling method and NATM. This method is used in difficult ground conditions such as fractured rock. NATM relies in the ground support, the rock bolt, shotcrete, and steel ribs. Next, for the detail sequence, is going to start with the detailed site investigation and design confirmation. It is to carry out the borehole drilling, geotechnical logging, and laboratory testing. It's also to conduct the geological mapping, hydrogeological, and geophysical survey. It's also to use to identify the faulty zone, weak rock, and also high groundwater pressure area. In this sequence, also it is to confirm the tunnel alignment and classification section for the TBM or ATM excavation. Next sequence would be the construction of major surface structure. The construction will be conducted at the Cloud Dam on the Sungai Kelau with the storage capacity approximately of 150 MCM. Next is to construct the Sematan raw water intake below the confluence of Sungai Kelau and Sungai Betong. Next is to install the piping system with a design with capacity of 2,260 MLD. Next is to establish construction camp, benching plan, and also workshop with the access road to the construction site. Okay. In the next sequence is the development of tunnel, portal, edges, and shaft. In this sequence, it will be construct a permanent portal at the Karak and Ulu Langat. Then is to excavate temporary access edits and ventilation shaft along the alignment. It's also to provide access for the TBM launching and ATM excavation, ventilation, and emergency egress. Next is to divide around the 44.6 kilometer tunnel into a multiple excavation drive. For the next sequence is the TBM assembly and launching. It's going to assemble a 3 hard rock, a main beam TBM, which have around 5.2 diameter inside the launching chamber. Then the TBM is installed with a backup system including a conveyor, power supply, and ventilation. Then this is conduct the TBM commission and trial operation prior to the full excavation. The fifth sequence is using the TBM excavation in the competent rock section. It is going to carry out a full face excavation using the disc cutter. The TBM is advanced using the thrusting against the rock using the gripper system, and all the excavation material is going to remove via the conveyor belt. The rate going to be adjusted based on the rock quality, cutter wear, and the groundwater inflow. Next is the sequence for the NATM drill and blast excavation in the weak or shallow section. The first one is to drill blast hole using the drilling jumper. Next is the conduct control blasting in the short excavation round. Any mark will be removed and carried out depending on the scaling of the roof block. Now the NATM machine is going to be observed with continuous monitoring. In the seventh sequence is going to be installation of the primary ground support. First, to install the systematic ground bolt or cable anchor. Next is to apply fire reinforcement shotcrete with the accelerator. It is recommended to fix the mesh wire to improve the shock grip performance. Next, the steel ribs or lattice grinder is installed in very poor ground. For the next sequence would be the probe drilling, grouting, and groundwater control in order to carry out any probe drilling ahead of excavation phase. Pre-grouting and consolidation going to be performed in the high inflow zone. Then temporary and permanent drainage system is installed in the construction site. It uses a high capacity dewatering pump to control the groundwater inflow. Next, I will pass to my friend as the next presenter.
After excavation and primary support, secondary lining and finishing are done. Cast in situ concrete and a concrete invert provide structural strength and smooth water flow, while waterproofing and joint sealing prevent leakage, ensuring a durable tunnel ready for operation. Installation of permanent mechanical and hydraulic system. After tunnel excavation, permanent system like water pipes, valve pumps, damage and drainage and monitoring equipment are installed to ensure safe and efficient water flow inside the tunnel. And TBM breakthrough occur when the machine reach the exit. The TBM is then dismerited and temporary support and equipment are removed, preparing the tunnel for final system installation. All systems are tested for proper operation and safety, including hydraulic check. After fixing any issue, the tunnel hand over to the authorities, completing the project.
For this project, I will briefly explain the main machinery used in the construction of the Pahang Selangor tunnel. The most important machinery used was the tunnel boring machine, or TBM. These hard rock TBM were used to excavate the main tunnel. This machine allowed continuous excavation and was suitable for the long tunnel length and hard rock condition. Behind the TBM, continuous conveyor system were installed to remove the excavated rock from the tunnel. This helped improve efficiency and reduce construction time. Ground support machinery, such as rock bolting and shotcrete equipment, was also used to stabilize the tunnel walls and ensure safety during construction. In areas where TBM could not be used, the drill and blast method was applied. Drilling machine and control blasting were used to excavate this section. In addition, heavy lifting equipment such as crane was used at tunnel portals and access point to assemble TBM component and handle heavy materials. Overall, the combination of these machineries enabled the tunnel to be constructed safely and efficiently.
Okay, I will explain about the challenges. The first challenges is geological issue. Deep excavation often faces geological challenges such as blocky rock and overbreak. Blocky rock is meant by large, hard, and uneven rock mass that slow the excavation. Meanwhile, overbreak is meant by uncontrolled rock breakage beyond the design line, leading to extra excavation and higher cost and stability issue. The second challenge is extreme hydrogeology condition. TBM encounter hot spring beneath the alignment. TBM while excavating beneath an area with hot spring, the groundwater entering the tunnel was recorded at the temperature of 56 degrees Celsius. High temperature increased thermal stress on worker and TBM component. So this project requires special cooling such as cooling fan and ventilation ducts. The third challenge is power outages issue. As each TBM continue on its 11-kilometer run, the machinery had to overcome power outages issue. This become a problem because the TBM heavily rely on electricity to operate the cutter head, conveyor belt, and other part of the machine. When a power outage occurs, the machine stop, which can cause the TBM to become stuck at the tunnel. So I will pass to the next presenter.
Thank you, Darren. Okay. Next is project management issue. The TBM machine become less effective when it takes a long time to excavate a tunnel, which also slow down the overall construction. Extended TPM operation require increased maintenance to ensure smooth performance. Okay, lastly, safety issue. Safety risks at TBM tunnel sites include complex geology, confined working space, poor lighting, lack of oxygen, and tunnel collapse. So, complex geology increase instability and rise the risk of accident involving personnel and equipment. Narrow underground construction space limit movement and visibility. Limited visibility may cause workers to misjudge distance, improperly position equipment, and detect hazard more slowly. Tunnel workers face the risk of insufficient oxygen and enclosed underground areas. Collapse of surrounding rocks and ground may lead to injury and death.
In conclusion, the Pahang Selangor Raw Water Transport Tunnel is a significant civil engineering project that shows the importance of tunnel construction in national development. This project demonstrates how proper planning, suitable construction method, and modern machineries are essential for successful tunnel construction. It also highlights the importance of safety, teamwork, and engineering knowledge in handling complex underground works. Through this assignment, we gain a better understanding of real tunnel construction practice. It improves our teamwork, communications, and presentation skills. Overall, this project helped us connect theory with real-world engineering applications and increase our interest in civil engineering projects. Technology, that's all for us. Thank you. Thank you for listening.
Okay, from what I learned is I know the purpose construction water tunnel in Malaysia.
For what I learned about the tunnel construction process, especially sequence and method.
Okay, I learned about a lot of machinery used in the tunnel construction.
I learned about technical term used in the project.
I learned about the construction method like TPM and drill and blast, and the importance of investigation, soil and